goal as law of sines. We're solving non-right triangles. The biggest thing that's different with when you have to use law of cosines versus law of sines is you don't have that matching pair. So you're going to have some, usually with law of cosines, there's more sides than angles. And most of the time you have, so that creates a little bit more difficult situation where you can't necessarily find more angles in there, because the more angles you have, then the better chance you'll be able to use law of sines. But usually if you have all three sides, you'll have to use law of cosines to find one angle. And once you find one angle, you'll have a matching pair. So then it's your choice whether you want to stick with using law of cosines to find the remaining pieces, or you can actually switch and use law of sines once you have that matching pair. So usually I switch just because law of cosines formulas are just a little bit longer. Not necessarily more difficult in my opinion, but just longer, and law of sines is shorter, so that's why usually I end up switching. But we're going to look at the formulas here first. You only use one at a time, so you don't have to use all three. And whichever one you use just depends on the information you have. And like I said, you don't necessarily have to have A, B's, and C's in your triangle in order to use law of cosines. Again, a lot of our triangles will be labeled with A, B, C, but as you know through our law of sines assignments, they don't always have to be. So essentially how they're all set up, and like I said, you can kind of see that they're really based a little more on sides, because we have a spot for all three sides in each one of our formulas, okay? So the way I kind of help remember which one's which, the angle, there's only one angle in each version of law of cosines, and that angle corresponds to the side that's on the other side of the equal sign, okay? So if we're talking about angle A, side A is what it's equal to over on the left-hand side. We're talking about angle B, side B is what's equal to on the other side of the equal sign. Same thing for C. If we're talking about angle C, side C is on the other side of the equal sign, and then the other two sides are used next to it. So essentially how it works with these first couple, these are squared, so you will have to square your sides here. And it kind of, it stems a little bit from the Pythagorean theorem in a sense, but like I said, it's not a right triangle, so they have to add this little part to kind of make up for that non-right triangle portion of it. So sometimes the sides are used twice, sometimes it's just once, but like I said, kind of the pattern that goes along with it, the side that's over here on the other side of the equal sign that's squared matches the angle on the thing that's with cosine. And then the other two are just the other two sides in the equation, and they actually get used twice. They get squared here first and added together, and they also get multiplied by this cosine. So, like I said, it's just kind of a longer formula. We substitute what we know in, solve for the thing that we're missing. So essentially what you have to have, like I said, you can have all three sides, because if we have all three sides, we can put it in for all the little A's, B's, and C's, and the only thing we won't know is an angle, so we'll look for an angle if that's the case. Or sometimes you might have two sides and an angle, so if we know these two sides, we can put it in for B's and C's here, and if we know angle A, we can put it into the cosine, so the only thing we wouldn't know is side A, okay? And like I said, usually why we end up having to use law of cosines is we don't have that matching pair. So if we have an angle but we don't have its side, we can use law of cosines to help find it. So like I said, if you have its angle, but the side that we're missing is the side that's across from it, so that's why it's equal to that side squared, okay? So now we're just going to go through a couple examples. Like I said, there's two possibilities. You either will start off with all three sides and no angles. If that happens, you obviously don't have a matching pair because you don't have an angle at all. So you can't use law of sines. You have to use law of cosines. Or you start off with two sides and an angle, but no matching pair. And there's no way to quickly get another angle other than using law of cosines. And that version's actually a little bit nicer. When you have all three sides, it just, the solving part of it gets a little bit complicated, just because you have to make sure you're really careful with order of operation when using this, okay? Because there's a lot of little pieces to this one. So we're going to look at, like I said, the two situations. We're going to look at one where we have all three sides, which is what we're going to do first, and then we're going to look at what happens if we have an angle and two sides. the triangle that I drew, so I'm going to give that my 19. And then so that makes this capital B, okay? Because my largest side was 19, so the angle across from it is B, so that's B. I would say that this side might just be slightly bigger than the other one, so that's my angle C. Like I said, if I want you to draw the triangle, I'll tell you. For my examples, I like to see it because I'm a visual person, so I like to see all that I'm using. And then I also like to label the triangle with all pieces, with all the pieces at the end. So that's why I like to draw the triangle. Okay, so if you notice with this one, we have all three sides, no angles. There's no matching pair because we don't have an angle, so that means law of cosines is out to start with. So it's actually, since we have all three sides, it actually doesn't matter which angle you find first. So because you can use any variety of law of cosines to help you find whichever angle we're looking for. Okay, so you can find angle A, B, or C. I usually like to find the biggest angle first. I don't know why, I just do. So is it okay if we find angle B first? So if you guys are okay with that? Like I said, it doesn't really matter which one you find first, but I just usually pick the biggest angle. Okay, so we're gonna find angle B first because it's across from the largest side. So the way I'm gonna set it up, you guys have them on your sheet right there, but I'm going to write it out here for you. Okay. So because I picked angle B to find, I'm going to pick that middle arrangement just because it's A, B's, and C's. So that's the one I'm going to use. Like I said, they're all essentially the same. You just have to make sure you get used to the order.
It's 2AC. Just I don't want you to do the problem. Screw it up.
Okay. Talking and writing at the same time. Okay. So, like I said, it really doesn't matter because, like the pattern that I tried to show you and tell you a little bit about the formula is the angle that you're finding should match the side that's on the other side. Okay. So since we're finding angle B, it's the B squared version of it. So I'm going to substitute my sides in. So I have 19 squared equals A squared, which is 8 squared, plus C squared, which is 14 squared, then minus 2 times 8 times 14. Because both of these two numbers match the two squares that you did originally in front of that cosine. And then we don't know the angle. So leave that capital. And then it's just an equation to solve. So we need to solve for our angle. And just kind of like when we're using law of sines to find an angle, the first thing we need to get by itself is the cosine. Before I do that, I call it cleanup. So that way we don't have all those squares and multiplications. So I'm going to go ahead and do all the squares first, and then I'll start moving stuff around. So 19 squared is 61. 8 squared is 64. 14 squared is 196. And then we got 2 times 8 times 14. Like I said, I just do a little bit of cleanup before I start moving stuff around, because then you don't get rid of the squares, and then you don't have all that individual multiplication in front of cosine. So there's a couple ways to go from here. Like I said, essentially we want to get the cosine by itself. So all of these numbers, you need to move away from it. You could clean it up one more step, and that's typically what I do, so that way I'm not moving as many numbers across the equal sign. You can actually go ahead and add these two numbers together, so I'm going to do that. Yeah, like I said, it's just a little bit longer, okay? That's why law of sines is better, in my opinion, but we have to use law of cosines every once in a while if we don't have that matching pair. Okay, now, you can add the two squares from the 8 squared and the 14 squared together, but I cannot subtract this number from that. Why? It's attached to cosine, okay? So remember order of operations, multiplication before subtraction. So never, ever subtract these two numbers, okay, together. So you can add these two together because they're separate, they're not attached to cosine, but this 224 is attached to cosine, so that just has to remain attached to cosine until a little bit later. So now, like I said, our goal at first is to get the cosine by itself. So we have two numbers. So again, we can't subtract these together because 224 is attached to cosine, 260 is not. But what I can do,
361 over the cosine.
I can subtract the 260 over with the 361.
I cannot do it on a calculator. Well, I was like, even I didn't miss sharp.
I know.
Normally I would.
Okay, now here's the other thing to watch out for. And like I said, I started with the kind of more challenging one because when we have all three sides, the solving part is really tedious because there's a lot of little things to make sure you're watching out for. Because what we don't know is the angle, and that's attached to the majority of what we had to substitute in. So we have to get that by itself. The big thing to watch out for is don't lose this negative, okay? So notice I kept that negative with the 224 because that's important because now to get the cosine by itself, since it's being multiplied by this negative 224, how do I get rid of the negative 224? Divide it, yep.
So we have to do this for all three angles?
Nope.
Oh.
Just one, and then you can switch the law sign. I mean, you could, but I don't typically choose to do that.
So technically you only have to do two because then you can just practice it. That's nice.
We got cosine by itself. We're almost done. Okay. So this is why you have to be careful with your sign because if you lost that negative, you wouldn't have had the negative with your decimal. So like I said, just have to, with law of cosines, there's a lot of little things, especially when you're solving for an angle. So we've gotten the cosine by itself, but that's what the cosine of the angle equals. And just like we did with law of sines, we get it down to this little decimal, okay, but that's not an angle. So what do you suppose we can use to convert this into an angle? Inverse cosine. Yep, we're going to use cosine this time because that's the thing that's in our problem. So we're going to do cosine inverse of that little decimal. And that will convert it into an angle. So 116.
What?
Did you use cosine?
Probably not. Wait, do I put the negative in the parentheses?
Yep.
Oh.
I'm just going to round to the nearest whole number. Since I didn't specify.
There we go.
117 degrees. We got one.
Yeah, 2 legs.
But this is why I like to leave them on the triangle. Because now that I have angle B, do I have a matching pair? Yes. I now have angle B inside B. So now I can switch and use law of sines again because I have that matching pair. Does that make sense?
Yeah.
Okay. I couldn't do that originally because it didn't have that matching pair. Now you are more than welcome to use law of cosines again to find either A or C. But like I said, for me, law of cosines is a lot longer. Okay. Not necessarily hard. Tedious maybe is a good word. A lot of little things to watch out for. So once I use it when I have to find that one angle, I'm going to switch and use law of sines instead of law of cosines to find A or C. And it doesn't matter which one you find next. So do you want to find A or C next?
A.
A. Okay. So, like I said, we now have a matching pair. So I'm going to switch and use the law of sines process that we've been working on the last few days. Okay? So I have 19 and sine of 117. And we picked angle A to find first. Now this is like finding an angle like we've been doing on the last couple of worksheets. So what we don't know is that angle still. So we still have more sides than angles. So we'll have to use law of sines to find that angle. But you'll find that finding the second angle is a lot quicker using law of sines than it would have been using law of cosines. So now we're going to cross multiply. So you have 19 times sine of A equals 8 times sine of 117. Divide by the 19. So I got 8 sine of 117 divided by 19. 375. Okay.
That was mean.
Alright.
Inverse cos to solve the sine problem.
Yep. So that's why you have to make sure you remember, am I using law of sines or cosines? Since I'm using law of sines, what inverse am I going to use to convert this into an angle? Sine inverse. Yep. So you do sine inverse of 0.375, and that'll give me angle A. So I got 22.
And then you can use the angle deal.
So now that I have two angles, I don't have to use either one of those again, because I can just do 180 minus 117 minus 22. So angle C.
This is on the ACT.
What?
It's like, what's the equation to solve for right angle?
Yeah.
Or not right
I
angle,
was like,
the angle of angle B.
well, that's annoying.
Well, now that I know it was the one that had 6 different,
There's so
That's
many
why I'm not
people.
retaking it until
What's very sad and the thing about that is you look at the board and you say, I don't want to spend that much time on this.
Usually, I don't know if they make you solve the whole thing.
No, they just say
It's
what's
like
the
which
equation.
equation and which.
Yeah, we know.
now that I know it was the answer that had 6 lines, and that I feel too.
Alright, questions about that example? Like I said, typically this situation we have more sides than angles. The solving part is not quite as nice because we actually had to move stuff around because we had to get the angle by itself. The second situation is not going to be as bad. There's no really So this time we actually have an angle. But we have a matching pair? No. Okay. So we have an angle this time, but we don't have the sine. Okay. So that's how you still know you need to use law of sine or law of cosines instead of law of sines. But then, like I said, once you have that matching pair, you can switch and use law of sines. Unless you want to use law of cosines, which you're more than welcome to do. Okay. This one is kind of a little bit more restricted of what you need to do. So that last one, we could pick whatever angle we wanted to find first. I always pick the biggest angle. I don't know why. I just do. It's usually what? So this one, we only have enough information to find the third side. Okay. We don't have enough information to use any one of the else because the only angle we have is angle A. And so the only thing we could find first is that third side, that little A. Okay? So we're going to use this version of law of cosines. Okay. So we only have enough information to use this version of the law of cosines because we know angle A, we know side B and C. We don't know angle A, so that's what's going to be blank here, okay? So we're going to leave A squared with nothing there. And so this is why it's not, this version of law of cosines is nicer, because all the stuff we know will fill in the right half of the formula, okay? So you won't have to worry about moving stuff around with this one, so it's just more of a calculating thing. So it's still little things to watch out for, but there's no longer stuff that you have to move away from the cosine, because we know B, C, and capital A, okay? So, here we go. 15 squared plus 10 squared minus 2 times 15 times 10 cosine of myself a little peace of mind, I usually do a little bit, so that way I know that the calculator won't mess it up. So I'm gonna do 15 squared first, which is 25. That's 100. That is 3. Okay. So like I said, I do a little bit, so that way I know for sure that my calculator is reading it right. Because sometimes if you don't put parentheses in the right spot or different things like that, it won't quite read it right, and I don't want to mess it up just because of a little calculator error. Okay. Usually we can get it down to this part. As long as you type it all at once, you should be good to go. Is that okay with everybody? So I'm just going to do 225 plus 100 minus 300 cosine of 115. And so that's 451.78. That seems awful big to be a side. Yeah, because it's not really the side, it's the side squared. So how do I get rid of this square?
Then you move over.
Square. So you get 21.3. Okay, so like I said, if you look at the amount of work we had to do to find a side, not quite as bad to find an angle as we did on the last exam. Does that make sense? Yep. So, like I said, this is really set up to find a side. So it's really nice when we have that angle to start with. When we don't have it, like I said, it just gets a little tedious to use. But in the long run, to find a side using law of cosines isn't too bad. Okay. But now, do we have a matching pair?
Yep.
Yep. So do you want to use law of cosines again, or do you want to switch and use law of sines? Right, exactly. It was a formality of asking.
You'll never have to go anything.
So do you want to find B or C next? C. Okay. So we're still finding angles, so we'll have to do the inverse here in a second. But again, just do your cross multiplication. So 21.3 sine of C equals 10 times sine of 115. Divide the 21.3. We'll get the decimal that equals. That's 0.425. And then how do we convert that into an angle?
Sine inverse.
Sine inverse, yep. You're using law of sines, so you use sine inverse. So sine inverse is 25. I just remembered my nearest degree. I thought that was okay. Okay, now what's left to find?
B.
B. Yep. So we just need to do 180 minus 115 minus 25, and that's not it. Okay. 40. So, have to use the law of cosine once. Like you can use it multiple times if you really want to. But once you use law of cosines to get that matching pair, you can switch and use law of sine.